Hi friends, so this video is going to walk you through how to do the BeanBunny evolution lab. And the reason why I really like this activity for us is because you're going to be able to see how evolution and genetics are related. So the question that we're investigating is how does natural selection affect the gene frequency over several generations? And the gene frequency, what we're really going to be looking at is the number of alleles within a population, okay? So in this activity, you're going to examine natural selection in a small population of wild rabbits. So evolution on a genetic level is a change in the frequency of alleles or how many alleles there are in a population over a period of time. Now, breeders of rabbits have long been familiar with the variety of genetic traits that affect the survivability of rabbits in the wild, as well as in breeding populations. One such trait is furless rabbits, which are like naked bunnies. They don't have any hair. And this trait was first discovered in England by W.E. Castle in 1933. So the furless rabbit is rarely found in the wild because the cold English winters are a definite selective force against it. They don't survive the winter. So in this lab, the dominant allele for normal fur is represented by a capital F. That's what's dominant. And the recessive allele, which means it has no fur, is represented by a little f. So the only way for a rabbit to be furless is if it inherits two recessive alleles. So in this activity, you're going to model evolution by natural selection of the gene frequency of two alleles. That's capital F with fur, lowercase f, no fur. You're going to also calculate the gene frequency of the alleles for each generation and then graph the frequency of the two alleles. So this activity has two parts. It has the answers, so it has the activity and the questions, but then I'm also going to be grading your graph as well. So you have to make sure that your graph includes all of those parts, like a title and labels and scale and all those things, okay? Now the materials, you're just going to have to look around your house and find things that that will work, okay? So in my house, I didn't have a small brown paper bag, so I am using an old like Ziploc baggie, and whatever you choose just needs to be able to hold your alleles. And this is the bag itself is going to represent the English countryside because you're going to be randomly pulling things out. So you can use like a cup, like a drinking cup. You can use a really deep bowl if you want to. You can use like a Ziploc bag if you have one. You could use your backpack if you wanted to. You could use like a small bucket or it's like a clean trash can. Just something where you can like pull things out of, okay? You're also going to need 50 objects that are two different colors. So if we were going to do this activity in class, I would have had red beans and white beans, but I don't have beans in my house. I don't have those dry beans. You might have dry beans in your pantry, but I didn't. So I had to think of something that I had 50 of. And since I've got two boys, we're a really big Lego house. So I just went into Tyler's Legos and I just chose red Legos and I chose white Legos. So I have red and I have white. You could use different colored beads if you have them. You could even go so far as to just take a piece of paper and just leave one paper white and maybe color in the other one black and then just cut out like 50 different shapes of them. It really doesn't matter what you choose. You just need to have two things that are about the same size that are different colors, okay? My Legos are not all exactly the same size, but they're pretty close, okay? The other thing you need are like paper plates. So I've got paper plates because I had them in my pantry. You don't have to have paper plates. You can even do this like on a whiteboard, or you could do this like on your floor. You just need like 3 of something, and you need to be able to label those different sections, okay? So those are kind of the materials that you're going to need for this lab. Just look around your house. If you can't find anything, then email me or send me a message on Remind, and I'd be happy to help you find some materials or kind of brainstorm what you might have available, okay? So let's read through the procedure. The first thing I want you to do is write a hypothesis that answers that question in if-then format, right? So our question is, how does natural selection affect gene frequency over several generations? So how is natural selection going to affect the furless rabbit? So what would you expect to happen to the furless allele? And what do you expect to happen to the allele that's dominant that codes for fur? Okay, so you need to answer that in if-then format. And then you're going to place your 50 red beans and your 50 white beans into your paper bag. So the paper bag or the bucket or the basket or the cup or whatever you're using, this is going to represent the English countryside, okay? So I have put my red and white Legos inside my bag right there. And I know that I have 50 of each because I very carefully counted, okay? Now, the other thing I want you guys to notice is that the number 50 is completely arbitrary. So this does not represent like the English countryside as it is now. This is just a starting point that's been completely made up, okay? So number 3, without looking at the beans, you're going to select 2 at a time, okay? So I'm going to close my eyes because my bag is clear, but if you have like a basket or a cup or whatever, just make sure you can't see them when you grab them, okay? So I'm going to reach in here and I'm going to grab 2 Legos, okay? And I grabbed a red one and I grabbed a white one, okay? So my red and my white beans, okay, because they have one of each, I'm going to put them on my heterozygous plate, okay? So the first bunny I pulled out was heterozygous, okay? And I'm going to keep doing this until I've got all of my selected. So the second time, I drew out 2 reds. So 2 reds are dominant. So I'm going to put those on my double dominant plate. And I'm going to keep doing that. Again, I'm not going to look while I draw them out. But hey, look, I got 2 white ones. That means that I would put them on my double recessive. 2 white alleles means that this bunny is furless. So I'm going to put this on my double recessive. And I'm going to keep going until I've gotten all of them drawn out. Whew. All right, the first time I do that, it's going to take a while, but as you'll see in a minute, it's going to get a little bit easier, okay? So I drew them out and I placed them in the appropriate place depending on what combination of alleles I got. So now I'm ready for number 5. To determine the number of bunnies for each genotype. So remember, each rabbit has 2 alleles. So you're going to take the total number of beans and divide by 2, okay? Now, when I drew them out, I tried to keep mine in pairs. So I'm going to tilt my computer. Hopefully you guys can kind of see this a little bit. Okay? But here's what my little setup looks like. Okay? And so now I'm going to count the number of bunnies I have in each plate, okay? So I'm going to start with my double dominant. And because each bunny has 2 alleles, this represents 1 bunny, okay? And so this one would represent another bunny. I'm going to count the number of bunnies I have in on each plate, okay? So I'm going to do my double dominant one first. I have 12 bunnies, okay? So I'm going to go down here, and in my first generation, the number of double dominant bunnies, I have 12, okay? So I'm going to do the same thing for my heterozygous bunnies. And remember, this is one heterozygous bunny. This is one heterozygous bunny, so I'm really counting the pairs of them, okay? And I have 26 heterozygous bunnies. So now I'm going to do the same thing with my double recessive bunnies. And again, I need 2 beans to represent 1 bunny. So this is 1 bunny, and this would be 1 bunny. So I'm going to count the number of bunnies. And I have 12 furless bunnies, okay? Now let's go back up here and read the directions. So I need number 6. So I'm ready for number 6. It says the furless bunnies all freeze to death in the cold English winter. So we're going to set these beans aside. So all of my double recessive I'm just going to put over to the side. Okay. I'm going to maybe put them back in the, I'm not going to put them back in my bag, but I'm just going to throw them out of the population because those bunnies have died. So because those bunnies have died, those genes, those alleles are no longer in our population of bunnies. So we are going to discard them and we cannot count them anymore. Okay. So now I'm ready for number 7. It says count the number of big F, which is my red, and my little f alleles from the remaining 2 plates. So now that I've discarded my white bunnies, my double recessive white bunnies, now I'm going to count the number that are left. Okay, so I'm going to add up all the red beans, and then I'm going to do the same thing for the white ones. Now, here's a little trick. Okay, I didn't take any of my red Legos out of the population. So my number of dominant alleles should be 50 every single time. Okay. Now that's not entirely true in real life because in real life, bunnies can come in, bunnies can leave the the area or the population. This isn't exactly true to real life, but it's pretty close. Okay. So I'm just going to keep going. All right. Now I'm going to look at my heterozygous plate because that's the only one I have with little f, with the white beans, or in my case, white Legos. And I'm just going to count the number that I have. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And I have 26, which interestingly enough is the same as the number of bunnies because each bunny has 1 recessive allele. So that makes sense. Okay. Now for total alleles, I'm just going to add those 2 numbers together. So 50 plus 26 is 76. Okay. Now for gene frequency, there is an equation right up here on the top of your paper. So you're going to take the total divided by, or you're going to take the number of alleles and then divide it by the total. Okay, so if I want the gene frequency of my big F, let me find my calculator real quick. Okay, I'm going to take 50 divided by 76, and then I'm going to multiply that times 100 to create a percentage. So my percent of gene frequency is 65.8. I'm just going to round to the nearest tenth, so 65.8. Okay. And now I'm going to do the same thing for my recessive alleles. This time I'm going to take 26 divided by 76, and again times 100, and I'm going to get 34.2. Okay? And I'm going to keep going. So let's go back up to our directions. We are now at number 8. So now we're going to place all of these bunnies that are left. We're going to put them back into our English countryside here. And we're going to do the same thing again. All right. So after I place all my bunnies back into the English countryside, I'm going to repeat these steps to obtain all 10 generations. Okay. So you'll want to make sure that you pull them out of your bag without looking. You may or may not get to 10 generations. Oftentimes, students are going to run out of white alleles, like the recessive alleles, before they get to 10 generations. So if you don't make it to 10 generations and your number either gets to 1 or 0 of your white alleles or your recessive alleles, then you can be done. And that's okay if you don't get to 10 generations. Okay? And I'm taking 2 grades on this. I'm taking a grade for the conclusion questions, and then I'm also going to be taking a grade for the graph. Okay. Now up here, there are instructions for the graph. So I want you to pay attention to number 11. It says to prepare a graph of your results. The horizontal, which is the x-axis, is the generation number, and the vertical, which is the y, is the frequency of alleles. Because you have 2 frequencies, one of them is dominant, the other one is recessive, this is going to be a double line graph. Okay? If you have any questions, I will have my regular office hours at 9:30 and noon. And then you can also email me or you can send me a message on Remind. Okay? Bye bye. Have a good day.